Final problem, in all likelihood, if we could even get to this place, but here it is. A plane is flying 650 miles per hour. Just so you know, that is a magnitude sort of vocab. So you can see I've labeled it. Here's the plane right here, 650 miles per hour. So that would be the magnitude of that airplane at that moment, direction and force. So here it comes, 72 degrees east of north. So I start north and I go to the east, 72 degrees, and there it is. A wind, now here comes a little tricky thing, is assisting the plane, blowing 27 degrees east of north. Well, if the airplane at that moment is right here, it's like the x-axis and the y-axis get moved. So now we've got east, and we've got south, and we've got north and west again. And the problem says 27 degrees east of north. So this little slice here is 27 degrees. Now the magnitude is 120, so the wind is coming from underneath the airplane. So the question is, draw a vector representing this. Well, the resulting vector would be right there, and they connect. So you can see, what is the resulting speed of the plane? Well, this is going to take everything that we've learned and kind of put it all together, because let's do a little math. This is 27, this is 90, I'm going to write those over to the side, plus, now what we have to be able to figure out is this little slice, and we should be able to do that pretty easily. So with the idea, boy, brain malfunction. Gotta be honest with you guys. All right, so I don't know if it was just the pressure of the last problem or what, but the geometry part of my brain just wasn't seeing this. So here we go. If this is 72, we know that this is 18, and if that's 18, we know this is 90. You see all these triangles? So 90 plus 18 is 108, meaning, oh, we should have been able to figure this out differently, 72 degrees. So, remember the old alternate interior angles? I think we got a little bit of that going on, so I didn't even see that. But if that's 72, I know that this is 90, so 90 plus 1 plus 72 is 162. If I subtract that from 180, I get 18. And guess what? I could have just used alternate interior angles right there. So, this is 18. Learning as I'm teaching. 108 plus 27 is 135. So, this angle is 135. Why is that significant? Because now I have a triangle. I'm going to draw it right here. Ish. 650. This is not to scale, so forgive me for that. 120. This is 135. And that is what we need to find. If we can find that, that is the magnitude of our resulting situation with our airplane's magnitude and the magnitude of the wind. So now we've got this situation. So this gets a little crazy. A, B, C. Now, I got angle B, so I know that B squared equals A squared plus B squared, that should be a C, minus 2AC cosine of angle B is my go-to, because I want to find B. Now this is going to get nutty because the numbers are crazy. But B squared equals A squared plus C squared, calculator special, minus 2 times A times C times cosine of angle B, which is 135, and I made that way too hard, but oh well, that's math. I'm going to hit pause and crank some of these numbers out, and then we'll resume the video in a second. Okay, so I've whittled it down pretty well. I didn't quite finish it, but this, multiplied all that out, And that negative, I just brought it along. Cosine of 135 ends up being negative, so we're subtracting a negative, which turns into a positive. And now I'm to this place, so let's finish it off. So 436,900 plus 110,308.7, and now I'm going to take the square root of that. 2087, enter. So I end up getting B is 739.7 miles per hour. That is the resulting length right there, which represents the magnitude, which represents the speed. So that's my answer to letter B. Now what's the direction of the plane? Well, that's the directional angle, which is 18 degrees. After 3 hours, how far has it gone? Well, we just have to multiply our speed times 3, and we get it's gone 2,219.2 miles. Congratulations, you guys. You have finished the last lesson of Pre-Calc A. All right. So have I. Maybe that's why I'm excited.